Figure versus table. Which should I choose? This is always one of the great dilemmas that we have when you're doing things, because you have to be able to figure out, should I use a table? Should I use a figure? Where should it go? Now, we're going to look at it from the perspective of thesis. We're going to look at it from the perspective of a presentation, and they are two different things. When we deal with this shows you a table. And what you see on this table is you see a lot of information. It's got dates, it's got other things. There's probably some places where we could cut down and make it a little bit more compact so that we can see things a little bit differently. When you look at it, it shows you standard deviations. It shows you statistical parts. So you get a lot of information in there. One of the things you have to look at is when you put a table together, you have to make sure that everything looks just right. Over here, we've got a 0 plus 0 standard deviation, which means it's 0, and there's no way that you could actually test that. We can see the same things on some other spots over there. So when you're doing a table, you have to make sure that you don't have these sorts of errors, because if you have these sorts of errors, they will show up and somebody will see it. If you look, this column is bizarre as far as statistics go, because you have a 20 plus or minus 6, which is an A. You have a 19.25 plus minus 6.58, which is a BC, and you have a 19.5 plus or minus 10, which is a BC. So all of a sudden that tends to lead you to believe that statistics may not be too good. So you have to be able to check these things out. This is a figure of the same sort of material. And in here, there's probably some ways that you could save some things down, but you have to be able to look at the statistical bars. And what do the statistical bars really mean? In this, you're probably looking for the best treatment, and the best treatments look like they're kind of in the middle, where you have these very tall bars, and the worst treatments tend to be the very small bars. So if you're presenting something and you have a limited period of time, this would actually be a better choice. This was taken from the recent election. I'm using this not to endorse one candidate or the other, but what I'm looking at is I'm looking at the way it's presented. You have a map of the United States, and it shows the red area, it shows the blue area. And all of a sudden you look at it and you go, there's a lot more red area than there is blue area. If you look at this graphic shows you, based on each square being one electoral vote in the Electoral College. And all of a sudden, large areas tend to turn into small areas, and small areas tend to become much larger. And it gives you a much better representation of the way that the vote actually went. So it's a better sort of graphic, but we tend to think of it on the map side. So what are you trying to illustrate? Who are you trying to show it to? What are you trying to deal with? And that's where something like this, you get two different types of graphics. If I look at this says it's iron, magnesium, calcium, potassium, and phosphorus concentrations in top growth of ryegrass as a function of aluminum chelate levels. This was taken out of a paper. And what you see is you've got different aluminum levels in your material, and out of that, they assay the top part of the plant to see what the iron levels were, and then they did statistics, and it says column means followed by different letters are significantly different at the 0.05 probability level according to Duncan's multiple range test. In the first column over here, that you go all the way from 88 as your low on your control, all the way up to 450 when HEDTA was used as an aluminum chelate. Now, what that means is that chelate probably picked up the iron and moved the iron up a little bit better than some of the other materials. When you look at magnesium, nothing happened. So this is a table. This tends to give you a lot of information so that you can compare a lot of things very quickly. This is a graphic representation of the same thing. Now, you can see this visually much more graphically, which means in a presentation, this might work very well, whereas the table might be somewhat confusing to somebody. This is a two-dimensional table, and you can see the three-dimensional table seems to have a better visual aspect to it than the two-dimensional one. But they represent exactly the same data. There are certain questions that you have to answer when you do this. First question, what are you trying to illustrate? Are you trying to give out all the numbers, or are you trying to give a rapid presentation of the material? If you are doing a thesis, tables tend to work much better because they give more information. If you're doing a presentation, graphics tend to represent things better. What's your audience? Are you talking to people who might not understand all the intricacies of all of the data, in which case you might want to go with a figure? Or are you talking to an audience that would pick up this material very quickly, in which case a table might be better? How much time is there for explanation? Because if I'm looking at the aluminum stuff, boy, I can go through that figure very quickly. But if I'm going through the table, that's going to take quite some time to be able to explain the whole thing. Which manner communicates best? Again, you're going to look at it. Difference between a presentation, difference between a thesis. And in a thesis or a published paper, you may want to go for the table over the figure when it comes down to a viable method of communication. But let's not forget, they always say a picture's worth 1,000 words. So when you're doing this, sometimes a picture shows it very quickly, especially in a presentation mode, where you can just throw it out there and people will see it and go, oh, I can see what's going on there. Whereas a table may take a whole lot of explanation to be able to deal with.